different ways on schematic drawings. In a piping system, arrows show the flow. Electrical diagrams do not use arrows. Instead, you must read the voltage. Remember that electricity flows from high voltage to lower voltage, or the color code indicated for the wires. It is very important, therefore, to know the special symbols for each system you work with. Is it an electrical circuit, a fluid power system, or a piping system? When you read various schematics, the lines have different meanings, and the symbols may stand for different things. Lines on a schematic show the connections between the devices in a system. But the meaning of certain lines depends on the kind of system the schematic shows. For example, a simple line of short dashes can have 3 totally different meanings. On an electrical diagram, it probably represents exposed wiring. On a fluid power diagram, it stands for a drain line. On a piping diagram, it means a vent line. This chart shows some other common lines used in schematics. Several kinds of lines may appear on a single schematic. Most schematics use only one thickness, the present standard, but they may use various combinations of solid and broken lines. Would you think all schematics adhere to standards? Yes or no? That is correct. Actually, they don't. High-pressure 600 psi steam lines in this piping system are shown as thick solid lines and thick broken lines. These are standard piping symbols for high-pressure steam and high-pressure steam return. Drawing standards are set by national organizations as an aid in providing uniform drawings that all trained persons can readily understand. Standards are not law, however, and some companies prefer to use their own line symbols. These symbols are usually identified in a legend, shown as symbols at the top left-hand corner of the sample diagram. If a drawing carries no legend, the best way to figure out what various lines mean is to use your common sense, plus a table of symbols. This table of symbols in your own good judgment will probably enable you to interpret the lines on most schematics you will need to read on the job. Do not guess at line meanings. Serious bodily injury or even fatal injury can result from mishandling high-pressure lines, electrical lines, caustic fluid lines, etc. Consult the project engineer if in doubt. However, there are other clues, as you will read in this lesson. Symbols. The meaning of certain symbols also depends on the kind of system the schematic shows. Most piping symbols differ from fluid power symbols, and electrical symbols differ from both. This chart shows 3 symbols that all mean the same thing in different kinds of systems. The first symbol represents a check valve in a piping system. The second is a check valve in a fluid power system. And the third is a diode in an electrical circuit. All 3 devices serve the same purpose, to prevent flow in one direction, but allow flow in the opposite direction. The symbols differ because the systems are different. All 3 of these symbols represent devices that permit flow toward the right. This direction of flow can be seen most clearly in the check valve for the fluid power system. Pressure toward the left would force the ball into the seat, preventing flow. Diagrams A and B, shown here, depict a chilling chamber refrigeration system. But diagram A is an electrical diagram, and diagram B is a piping diagram. It would be impossible to tell the drawings apart by their titles alone. It is the symbols that tell you what kind of drawing you are looking at. In diagram A, the fuse, the switch, and the ground symbols tell you that this is an electrical diagram. The symbols for the expansion valve and the soldered elbows in diagram B identify it as a piping diagram. Symbols often look like the devices they represent. With that in mind, what do you think this symbol represents? Valve? Control knob? Gauge? That is correct. It looks like the face of a gauge with a pointer on it, which is exactly what it means. Interpreting a combined symbol is often a matter of common sense, based on your knowledge of what other symbols mean. This example shows 3 piping symbols. The first is a flanged reducing T that cuts down the size of a branching pipe. The numbers indicate that the main line is 4 inches in diameter and the branch is reduced to a 2-inch diameter. The second symbol is a screwed elbow, also called a threaded elbow, that turns the pipe 90 degrees. Elements of the first 2 symbols are combined to produce the third symbol, a 90-degree flanged reducing elbow. Other clues. It is usually not difficult to discover what kind of system a schematic portrays. Many clues appear on the drawing. The drawing has a title. The title usually describes the system as electrical, fluid power, or piping, but sometimes it does not, as shown again in these diagrams. The drawing may have a legend. The legend, remember, contains special information about what various lines and symbols mean. You should always read a legend carefully. There may be a list of parts and the symbols used for them. Words are often a part of the drawing. Numbers are often listed. For example, numbers may indicate voltages or the sizes of pipe, as shown here. Notes by the engineer or technician who prepared the drawing may make it clearer. Schematics are so important in maintenance work that you should understand how a schematic is created. This example contains 5 elements that can be combined in an electric circuit: a battery, a switch, a generator, a motor, and some wire. The purpose of this circuit is to run the motor from the generator with the battery as backup power. The engineer who designs the circuit can accomplish the purpose with several different arrangements of these elements, but the engineer needs to consider more than just delivering the required voltage to the proper points in the circuit. The physical size of the circuit must be considered. The efficiency may be important. The circuit may need to be shaped to fit as part of something larger. The cost of the circuit may be the most important factor. In addition, there are building codes, electrical codes, and other factors to consider. An engineer usually makes several sketches. He may also make several lists of materials. 1 or 2 of the designs might look as though they meet all the objectives of the system. If necessary, these designs can be tested in the laboratory before a final decision is made. When the engineer's final design and the list of materials have been approved, the schematic diagram can be made. The schematic is the diagram you will see and use. The design information from which it was drawn goes into the engineer's notebook, into the company files, or even into the wastebasket. Suppose the arrangement shown in the diagram on the left turns out to be the most appropriate one. The engineer then changes the words into symbols and perhaps adds a few words to make sure that the schematic is completely clear. After making the appropriate changes, it becomes a schematic version of the first drawing. As this is a DC circuit, current will always flow from negative to positive.
Click a tic-tac-toe square and answer the corresponding question. Get the correct answer and a circle will appear. Try to get 3 circles in a row to win the game.
Using the schematic. Differences in schematics. Even the most important function of a system, the control and delivery of flow, is shown in different ways on schematic drawings.